You're not live. Hi everyone. I'm logged in a little bit early. Hi Lindsay. Hello. Hi everyone. Hi Mary. Hello. Ooh, I can wave to you. Okay, so we are here with Need doing Instagram Live. And I know it's going to take a few minutes before people get logged in, and I'm watching for somebody that I'm going to pin their comment to the top, but I'm not sure. Is that going to be, hello, is that going to be Becky that I'm pinning? I guess let me know when you've got a comment that you want me to pin. And everybody else, hello out there, welcome. This is Need Instagram Live. We're going to be doing some fun STEM today. Here we go. Here to answer questions. Yay. Okay. All right, we are going to be building an anemometer today. It's a device to measure wind speed. I'm going to tell you about some of the materials. We're not going to actually build it till a little bit later, but if some of you needed to run around and get supplies, I just wanted to tell you what you would need. So you're going to be needing 5 cups. I have some snow cone cups, and I know some of you at home have these too, but not everybody does. You could also use Dixie bathroom cups. You could, I think this might work if you made some origami paper cups. I found on YouTube some simple directions to do that. So if you are home and you can't get to the store, that would be an option to just make some out of paper. So 5 cups is what you'll need, maybe even some plastic cups. All right, pencil. You're going to need 2 extra long straws. You're going to need some tape. If you have a hole punch, grab a hole punch. If you don't have a hole punch, you know you could just take your scissors and kind of jam them into the cup carefully. Or you can take a sharp pencil and poke that through. So scissors is another thing that you're going to need. And you're going to need a straight pin. So straight pin like this. I'll go through those materials again a little bit later, but I wanted to just mention that at first in case anybody was watching and they wanted to go around and gather up those supplies. Kimberly is here to answer questions, so if I'm talking and busy doing things and I miss something that you say, then be sure to let her know and she'll answer. All right, so I'm going to go ahead and just start talking about some different things, knowing that some people might be joining us a little bit later. So first of all, if you're there and you can comment, I have a question for you, and that is it windy today? So wherever you are watching from, how would you answer that? Is it windy? While we're waiting for some responses, I'm going to flip my camera around and let you see out my window here. If I'm looking out our back window, watch for a second and think, how would you answer that question here? Oh, okay, Cindy says yes, and blowing snow. Oh no. All right, leaves blowing on trees. Right, because we can't see the wind, it's invisible, but we can see objects that are moving. I've got somebody that's Becky saying it's a little windy here. Yes, blowing snow, leaves blowing on trees. Oh, the bird feeder in the tree is swinging around. And I'm guessing people are watching from different parts of the country, and so it might be windy in one place and not in another. So I'm presenting to you from Illinois, so in the Midwest. This is what you're seeing today. We did have snow this week too, unfortunately. But when you're looking to see if it's windy, you can't see the wind, you're just looking to see what objects are moving. And it's not going to be the same everywhere in the country at the same time. And why is that? Because this is it's a live broadcast. It's April 16th. So if it's windy here, why wouldn't it be the same everywhere else? So if anybody has some ideas they want to jump in with, why would we have it be more windy in one place and less in another? You could jump in with your comments, but I'm going to go ahead and show you a couple of things. So first of all, what causes wind? We have radiant energy coming to the earth. This volleyball is going to be the earth today, from the sun, flashlight. I often ask kids, where would it be warmer? where we live or Dallas or Florida. And the kids will know that it's warmer in Dallas or Florida, but when I ask them why, they'll say, well, it's because it's closer to the equator. True, but why is it warmer closer to the equator? So this is a demonstration that we do in class. If the sun is shining on the Earth, you're going to see that it's more concentrated at the equator, but due to the curvature of Earth, that light is more spread out as it's going over that curve. If I show you with this flat piece of paper, you'll see that direct 90-degree angle, which is how it's hitting the equator, gives us that circle where it's really concentrated light. But if we were to angle this, you'll see that circle starts to spread out. We have more of an oval. So it's the same amount of light, but it's being spread out. And this is what happens with Earth. So the sun is still shining in Alaska, but it's not as direct and intense as it is right at the equator. So that means that materials on Earth are heating up and we're getting different amounts of light. The different materials on Earth are going to heat up and cool down at different rates, which is something else that we've done in class, where we've taken soil, sand, water, air, heated them up, cooled them down by putting them in the sunlight and then in the shade. And we saw that water, soil, they don't all heat up at the same rate. And this causes differential heating, which is what causes wind. So something else that we've talked about is convection currents. Warm air rising, cold air sinking, and those convection currents are causing wind. All right, so a couple other things we're going to do is model what's happening with those particles as they're heating up. So if you're joining me and you're one of my students or former students, you know that I would have you do this to model things that we can't see, like particles of air, by taking two fists and making those particles like this. So if you were in class with me, I'd be telling everybody, okay, put your fists up, make those molecules. They're moving around. And as they're heating up and gaining kinetic energy, they're going to start moving faster and faster and bouncing farther and farther apart and going crazy. And then don't hit your neighbor. And as they're cooling down, they're going to get slower and slower and get more close together. And so we know that they're getting less dense as they're getting farther apart and heating up, and they're getting more dense as they're cooling down and getting closer together. So we're modeling what we can't see, those particles of air. And here's another little model for you. Got our particles of air that are really close together and dense. You'll see they're sinking down to the bottom. And then we've got our molecules of air after they've been heating up and they're spreading out and becoming less dense and taking up all that space. So this less dense air is rising, colder, more dense air is sinking. And again, particles of air that we can't see, but the models allow us to see that. And one other demo. This is something that we have done in my classroom too. You could try this at home. You just need some room temperature water. And what I do is I challenge the kids, so some of you might remember doing this. I give them some hot water that's dyed red and some cold water that's dyed blue. And I challenge them to layer those liquids by showing me that you have a red layer, you have a blue layer, you have some water that's still clear. Get them to layer without mixing. So we'll try that now. You would need some food coloring, cold water, hot water. We use an eyedropper at school. You might not have an eyedropper, but if you have a straw, you can turn this into a little dropper. So a little trick, you guys have probably done this before. Put the straw in, put your finger over the top to make a vacuum, lift it up, and then you can get that water to come out. I used to get in trouble for doing that at restaurants with my chocolate milk. So maybe you guys have played around with that before too. So I've got some blue ice water. And I've got my thermos here with my red hot water. So in class, I just challenged them to figure it out, and they would try different things. It would get mixed up. But what I'm going to do now is, spoiler alert, show you what happens. So if we get our cold ice blue water, I'm going to put that in the jar and then just let it go slowly. Okay, you'll see what's happening. That water is sinking down to the bottom as it's coming out of that straw, because this water is colder, more dense. Same thing would be happening if we just had clear, cold water and hot water, but it would be pretty boring because you couldn't see it. So there's our cold, more dense water sinking. And it might be easier to see if I put this paper behind it. Okay, now if I put some hot water in, and again the hot water is dyed red. I think I better put this closer. All right, there you'll see my warmer, more dense water is staying at the top. My warmer, less dense water rising to the top, my colder, more dense water is sinking to the bottom, and I've got my 3 layers of red, clear, and blue at the bottom. So the same thing happens with the air. It's not so easy to dye the air. We have done that before with a smoke match, so that we can see in the convection chamber that same thing, the hot air rising, cold air sinking. It's a little bit easier to see with the water, but water is a fluid and air is a fluid too, anything that flows. So gas can flow from one area to another. And again, this is all demonstrating what is causing that wind. Okay, I'm gonna go through the materials one more time in case you had joined us later. We have 5 cups that you're gonna need, a straight pin, 2 longer straws. You'll need a pencil, a hole punch if you have one, and scissors, and a marker. I should have mentioned that earlier too. A marker to color one of those cups. So we're gonna be making the anemometer shortly. One more thing to talk about before that, and that is if we wanted to know how fast the wind is blowing, there are a few different things that we can do. And the first thing you had mentioned before when I asked you about if it's windy is you looked outside to see what the objects were doing, how the objects were moving. So there is a scale we can use. It's the Beaufort Scale. And I've got some little illustrations to tell this part. If you were to see smoke rising vertically out of a chimney and the smoke is just going straight up, you would know that it's calm and the wind is less than 1 mile per hour. On the other end of the scale, we have 12. 12 would be over 72 miles per hour winds. You would definitely know the wind is blowing. You would have a hurricane, widespread damage. This is my palm tree that's blowing in the wind. So we have from a 0 to a 12 on the Beaufort Scale, but we know that a lot of the times it's in between these two. So the Beaufort Scale, you can look and see what objects are doing to tell how windy it is. I thought earlier today when I looked outside, I'm going to go ahead and do this reverse again. If you look outside and see those trees in the back, you'll see some of those smaller branches are moving in the wind. And I thought earlier when I looked at that it was about a 4. So a 4, here's my picture of some loose papers blowing, some of those smaller branches moving around. About 13 to 18 miles per hour would be a 4, a moderate breeze. Here's another one that would be in between the 0 and the 12. A 6 or a 7 on the Beaufort Scale. Here's my artwork of somebody just struggling to work an umbrella. The wind is whipping it inside out. Her hair is blowing, the skirt's blowing. So this would be a strong breeze or a near gale, a 6 to 7 on the Beaufort Scale. This is where it would be really hard to walk. You're struggling to walk against the wind. So these are some ways we can estimate wind speed by using the Beaufort Scale and looking at those different objects. But today you're going to be building an anemometer, which will be another way to calculate wind speed. So we'll go ahead and start making that now. First thing you're going to do is take a cup. If you are using a Dixie cup, I'm going to just be cutting off the bottom, but you could be poking a hole at the bottom of your cup. So you're just going to snip off the bottom of your cup. It only needs to be a big enough opening for a pencil to fit through, so it doesn't need to be very big. So that's step 1, is just to snip off that bottom. Then you're going to be punching holes in the cup. 2 of the holes are going to be really close to the rim, and you're going to want them to go right across from each other. So if you imagine that this is a clock, you could punch them at 12 o'clock and 6 o'clock, those holes close to the rim. You're going to then punch holes at 3 o'clock and 9 o'clock, but this one you want to be a ½ centimeter below those first holes that you punched. A centimeter is about the width of your pinky, so go a half of that below those. on the opposite sides. So you can go ahead and punch those now. So you've got your four holes, 2 of them higher, 2 of them lower across from each other. And the reason why is because now we're going to be putting these straws through, and you don't want them to hit each other in the middle. So the other one's going across this way. And they're going to make a little crisscross like that. You want to get them centered as much as you can, although you'll be able to move those around a little bit later. And try to say anemometer 3 times fast. Okay, now that you've got this made, you're going to set that aside. With your remaining 4 cups, you're going to take one of them and one of them only to color. This is because when your anemometer is spinning around, you want to be able to see one of them is different from the others to help you count how many revolutions it's made. So you'll take your cup and color it and choose a dark color or a bold color, like I said, that will really show up. So go ahead and color that cup in. And I kind of thought that this might be boring to watch me color a cup, so I do have one that's already made. Ta-da, just like on a cooking show. So you're coloring in that first cup. You might want to decorate your anemometer, but it's really going to be a lot easier to see if you just color one and leave the other ones plain. So now with your 4 cups, all 4 of them, you're going to punch 2 holes about 1 centimeter from the rim, 2 holes right across from each other. I'm going to demonstrate this with 1, and then I'll show you how this goes on so that if you are working with me, you can kind of go ahead of me. So you're going to put the cup on the end of the straw, and then you'll be taping it in place so that it goes sideways like this. If we just let it hang, it's going to do this, and we want it to go sideways. So if you're following along with me, this is what we're going to do on all 4 of those straws. So go ahead and add a little bit of tape to each of those. You can put a little bit on each side. You want to make sure they're all going the same direction. So you may need to kind of turn it and watch as you're making it to make sure that they're all going the same direction. And if anybody has any questions, go ahead and chime in. One thing that I'll see kids do in class is they'll want to put the other one this way because it looks like they're going the same way. But if you turn it in front of you, you'll see you always want the open end to be going the same way. So I would take it and turn it just to make sure that you've got them all going that way. Okay, I'm gonna, again, with our magic of video, go ahead to the next part. This is where you're gonna take your pencil and put it through that center cup, and you're gonna wanna center it as much as you can and take your straight pin, poke that through those 2 straws to go into the eraser. And ideally, you're gonna want all of these cups to go sideways. You want them to all be facing that same direction. And if your anemometer is not spinning quickly enough, you might want to just take that straight pin and sort of wiggle it, push against the straws to sort of widen those pinholes to make it spin a little more easily. And then once you have it made, you can test it by either going outside or using a fan if you don't have wind where you are today. So I've got this little handheld fan. And sometimes it takes me just getting it at the right angle. There we go. So you'll see as it's going faster, this is why it's helpful to have that 1 cup that's colored a darker color so that you can count those revolutions. Like a pinwheel, yes. All right. I don't know if we have any other questions out there. All of the activities that this is the anemometer that we built today, the Beaufort Scale, that information you can get in this Energy from the Wind guide. If you go to need.org, you can download their curriculum for free. So all the directions are there. If you wanted to see the full Beaufort scale with all of the descriptions 0 to 12, when you're finished building your anemometer, take it outside and you're going to want to time it 10 seconds. How many revolutions do you count in 10 seconds? And then the scale will tell you how many miles per hour the wind is blowing. Try that. Try going to a few different locations, because you might get a different reading at the back of your house than you do at the front of your house. And after you've made yours, check to see how reliable is it. How does it compare to maybe a friend who made one too? And then see, is there anything you could do, any way you could modify your anemometer to make it more reliable? All right, so I know that I tend to talk a little faster when it seems like it's going to take longer than it does, and then I start talking really fast, so I hope I didn't go too fast and go over and miss anything. But if anybody out there has a question, you can ask it now. And otherwise, I think that's it. All right, well, thank you for joining us. And Kimberly is here too. Okay, full video is going to be on the YouTube channel later, so if you're just joining us and you missed it, you could always check it out later. And I guess that's it. So thanks for joining us. Need Project is doing Instagram Live on Tuesdays and Thursdays, so check back next week for more distance learning STEM. All right, thanks everybody. Bye.